Simple proof, yet powerful applications. So there's this integral from 0 to 1 log x to the power n 1 minus x dx, right? This integral comes pretty handy while solving lots of problems, like just like my next video. There's a really good integral, and I will be using this formula, so that's why I'm doing it right now. And yeah, let's see how do we solve this integral. It's not that hard, but it's really like powerful. There are special functions over here. This gamma of n plus 1 is just n factorial, and for real numbers, it's defined as this integral. Yeah, e to the power n e to the power minus t dt. Now, similarly, this Polylogarithm function is a really powerful function that generalizes a lots of special functions like Riemann zeta and a lot. This is defined as sum from n equals to 1 to infinity of basically okay, n is already used, sum from k equals to 1 to infinity of z to the power k by k to the power n. And its integral representation goes like this. Basically, it's defined by some recurrence in integral. So first of all, Li 1 of g is negative ln of 1 minus x. And then after that, all Li of n plus 1 z's are defined as integral from 0 to g of ln of x by x dx. So this n is subscript, right? So this is how it's defined. But you don't really need all this definition. You just need this much information to deal with it. Okay, let's see how do we do that. We have integral from 0 to 1 log x to the power n by 1 minus ax dx, right? So we're going to make the assumption that the modulus of a is less than 1, because if that's the case, the modulus of x is also less than 1 because it goes from 0 to 1. Then modulus of x is less than 1, and that means we can use the geometric series, right? Which gives us sum from k equals to 0 to infinity of ax to the power k dx. Now we can take log inside the sum in the interchange sum and integral, which gives us sum from 0 to infinity, integral from 0 to 1 of a to the power k, x to the power k, log x to the power n dx. I can actually take a to the power k outside the integral because that doesn't really depend on x, right? And with the remaining terms, I can actually use the gamma function, right? This is a standard integral, and its value is negative 1 to the power n gamma of n plus 1 by k plus 1 to the power n plus 1. You can actually get this by making a u substitution that u is negative ln of x, and then it's just gamma function, yeah. Now for this one, you can actually take negative 1 to the power n and then gamma n plus 1 outside. That leaves him with sum from k equals to 0 to infinity a to the power k by k plus 1 to the power n plus 1, right? But notice that it's so similar to this thing, just that it runs from 1, but it runs from 0. So if you want to make it run from 1, you can actually first of all divide this by a, and then make this look like a to the power k plus 1 by k plus 1 to the power n plus 1. So since there's all of these are just k plus 1, what you can now do is make this sum go from 1 to infinity and then replace k plus 1 just by k. And now we see that this is actually in the form we want, and we know that this one is actually li subscript n plus 1 of a, right? And that's the formula we actually wanted to prove. And the benefit of having this formula is, like, mathematicians over the centuries have found formulas for most of the polylogarithm functions, right? And since they have already found out those polylogarithm function values, it's helpful for us to just use them, right? Instead of really deriving, first find answer in terms of polylogarithm function and then just use those values. So that's how it's helpful, because in the next video also I'm gonna find answers in terms of polylogarithm functions and then just substitute the numbers that mathematicians have already arrived with, right? That's how it's helpful. And then yeah, this is how we derive it. Let me check if it's right. 9 to the power n gamma of n plus 1 ln plus 1 of a by a. Yeah, that's right. So just to summarize, refers to its infinite series, and then gamma function and the definition of the polylogarithm function, and that's it. It was simple. It was so simple proof, but like in my next video while I'm doing an integral, this simplifies the problem so much, and then problem like just become a child's play. So yeah, you will see in the next video. Thanks for watching. I also look forward to seeing you in the next video, and have a great day.